Hi, this video is going to be kind of an introduction to electron configuration. There'll be a second video that gets into the noble gas electron configurations and how to use the periodic table to write electron configurations. So electron configurations are a way to kind of describe where the electrons are located to the best of our ability. We don't know exactly where they're at, but we do have, high probability of finding them in certain areas. So when we write the electron configuration, so this is really my N. N is 1, which means I'm in the first principal. My principal quantum number is 1. I'm in the first energy level. The S here is a sublevel. And then this upper superscript is the actual electron. So this is telling me that I have 1 electron in the first energy level in the S sublevel. We also use orbital diagrams. The box is going to be an orbital, and an orbital can hold up to 2 electrons. So these arrows are the electrons, and for them to be together in the orbital, they have to spin opposite one another. So we have what we call the Aufbau principle. This is just that electrons will go into lower energy orbitals first and then into higher orbitals if needed. So electrons are going to start here at 1s, then they go to 2s, then 2p, 3s, then to 3p, 4s, and then actually the 4s is the surprising. So in a way you would think it goes 3s, 3p, 3d, but the 4s is slightly lower in energy, so it goes there and then goes to the 3d. So I'm going to show you how to use that in just a second. But I do want to talk about a couple different things. So we've got Aufbau's principle, which is electrons will enter the lowest energy orbitals first. Pauli exclusion is just this right here. So if the electrons are both in the same orbital, they're going to have opposite spins. And this should sound kind of familiar. This is the 4th quantum number, m sub s, but we call it the Pauli exclusion principle. Hund's rule is they call it the bus rule because when you ride a bus, now that you're older, most people kind of take their own seats and then they double up if needed. So this is an example right here. These 2 electrons each went into their own orbital. And if I had a third, they're all going to spin in the same direction. And then if I have enough, then I will start to double them. So I only double them up once every equal energy orbital has 1 electron. So these are examples of what Hund's rule is not. So you don't want to have them spinning opposite like they are here. They would all spin the same way in their own orbitals. This one here, the second electron should go in its own orbital. Orbital diagrams are when you do the box and arrow like this. We are going to draw some of these also. So an example, and I'm going to go back, we're going to do silicon. So I'm going to go back here. So if we were to figure out a silicon's electron configuration, and then we'll also do the orbital electron configuration, the first thing I'm going to do is I'm going to look up silicon on my periodic table, and silicon has 14 as its atomic number. So we're going to assume it has 14 electrons. So if I place those electrons, I'm going to put them in the bottom first. So this is Aufbau and these arrows. So right now I placed 4 electrons. So then 5, 6, 7, that's Hund's rule. So 2, 4, 6, oops, I can't talk. I'm going to keep filling. And then just wait, what am I doing? 3s2. And then 3p2. So This is just a tool that you can use. It's in your textbook to help you to write the electron configuration. So I'm going to translate this now. So it would be 1s2, those 2 electrons in the first energy level, 2s2, 2 electrons in the second energy level in the s sublevel, 2p6 is these 6 electrons right here, 3s2, and then 3p2. So if we were going to do the orbital notation for this, we would draw single boxes for the s because they only have 1 orbital. So 1s2, 2s2. When I draw the p's, we have 3 orbitals, 2p6, and then 3s2. And then even though I only have 2 electrons, I'm going to draw all these 3 orbitals. So if it were a D, I would draw 5 boxes. F, I would draw 17. I mean, can't even talk. I would draw 7, sorry. So this is the orbital diagram for silicon. I want to talk about valence electrons. So valence electrons are the highest energy level electrons. So to determine those, we would see that n equals 3 is our highest energy level, and then these are my valence electrons. So there's 4 valence electrons for silicon. You can also see it in this diagram. So if I were to do what we call an electron dot diagram, this is where we write the symbol. And the symbol is really representing all of the inner, what we call core electrons. So really, it's these electrons now that are represented within the symbol of the element. And then I'm going to place these 4 valence electrons around, starting at 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock. So just to review, and then we can do a couple more together. So let's do one of these that's on your worksheet, atomic number 8. So we would look on the periodic table and find that that's oxygen. So we need to place those 8 electrons. So I'm going to use this diagram. So there's 2, 3, 4, 5, 6, 7, 8. So when I write the electron configuration, I'm going to write that as 1s2, 2s2, 2p4. And then over here, I'm doing an off-bow diagram just of the valence electrons. So I'm going to pick my highest energy level, which is 2, and then you can see that there's 6 electrons. So I'm going to do 2s and 2p. So I'm only doing those valence electrons. And then I'm going to come over here and I'm going to add electron dot diagram. And this is where I'm going to do that symbol. Remember, that represents all of the electrons, but without the valence. Then I'm going to place my 6 valence. So 1, 2, 3, 4, 5, 6. So now you can see that you do want to double them up, and they are in pairs, and you want to make that really clear. So starting at 12 o'clock, 3, 6, 9, and then you double them, and then they're paired up. So let's see if we want to do another one. So this one is chlorine. And chlorine then would have 17 electrons. So we would have 1, 4, 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17. So when I write the configuration, it's going to be 1s2, 2s2, 2p6, 3s2, 3p5. These are my valence electrons right there and there. So when I show those, I'm going to go 3s, 3p. These are the 2 electrons. And then here are the other 5. So you can see there's a total of 7 valence electrons. So I'm going to draw chlorine, 1, 2, 3, 4 electrons. Now I double up, 5, 6, 7. So I think I'm done. So doing the worksheet right now, I would recommend that you do the ones that are under the dark line. And then after that, I would go and watch